Planes pi1 and pi2 are given by 3x plus 2y plus uz equals 21 and 2x minus y plus 2z equals 7. Given that the line with equation r is equal to bj plus ck plus t times I plus dj plus ek is common to both planes, part A asks us to show that d is equal to 2 times u minus 3 divided by u plus 4. Okay, so the first thing to realize here, if we do have two planes, so let's say this is pi1, and then pi2 intercepts it like this. Now let's label the line of interception L. Okay, then something to observe is that L is going to be orthogonal to both normal vectors of the plane. So if this plane here is pi2, then we call this vector n2, so this is a normal vector of pi2. Then let's let n1 be a normal vector of pi1. Then this line that is perpendicular, well, that is on the intersection of both planes, it must also be perpendicular to both planes. So if this is the direction vector of the line B, then we know B is a vector that is orthogonal to n1 and n2. And if you're not sure why, just observe that the vector B is parallel to both planes. So since B is parallel to both of the planes, then by the definition of the normal vectors are orthogonal to every vector that is parallel to the plane to which it is a normal vector of. So therefore, both these normal vectors have to be orthogonal to the vector B, and therefore the vector B is orthogonal to both of the normal vectors. And now that we know that B must be some multiple of the cross product of n1 and n2. So k times n1 cross n2. Now n1 is the vector 3, 2u, and n2 is the vector 2, negative 1, 2. And of course, this is our vector B that we're talking about here, the direction vector of the line, which is 1dE. So it's also equal to 1dE. Okay, so let's go ahead and solve this thing. We have k times, if we delete the first row, we get 2 times 2 is 4, minus negative u is 4 plus u. And then if we delete the second row and calculate the determinant backwards, it's going to be 2u minus 6. And then if we delete the third row, we get negative 3 minus 2 times 2, so that makes negative 7. Alright, and this should equal the vector 1dE. And so according to the first set of coordinates, we have that k is equal to 1 divided by 4 plus u. And then according to the second set of coordinates, we have that d is equal to k times 2u minus 6, which is equal to 2u minus 6 divided by 4 plus u, which I think is what it was supposed to equal. To 2u minus 6 divided by u plus 4. Yes. So moving on to part B then. We're told that the letter B, which is this one here, is equal to negative 2. So it asks us to find the acute angle between pi1 and pi2 correct to 3 significant figures. Okay, so we know that B is equal to negative 2. And since this line here which we now know to be r is equal to -2, oh no, I'm sorry, it's 0i, and then -2j, and then ck, plus t times 1 dE. So we know this line is in both planes, which means all the points on this line are in both planes, which means that the point when t is equal to 0, which is 0 to c. So let's call it the point P, 0, -2, c, is in both planes. So that allows us to find c using the equation of the second plane. So we have 2 times 0 minus -2, so -2, oh sorry, minus -2, so plus 2, and then plus 2 times c is equal to 7. So that means that c is equal to 2.5. Alright, so after moving this working down to where it should be, we have that c is equal to 2.5, and that means we can find u, because the point P with coordinates 0, -2, and 2.5 is in both planes. Okay, so that means it should obey the equation of pi 1, which is 3x plus 2y plus uz equals 21. So subbing these points in, we have 2 times -2 is -4, plus 2.5u is equal to 21. And so that tells us that 2.5 times u is equal to 25. And so that means that u is equal to 10. And now we have our vectors n1 and n2. So we know that n1 is 3, 2, 10. And n2 is the normal vector of the other one, so 2, -1, 2. And now to find the angle between our two planes, all we got to do is find the acute angle between our two normal vectors, whichever one happens to be the acute one. Alright, so theta, so we have n1 dotted with n2 divided by the length of n1 times the length of n2 is equal to cosine of theta. Okay, so n1 dot n2, so 3 times 2 is 6, minus 2 is 4, so 24, divided by the length of n1, so the square root of 9 and 4 makes 13, plus 100, so 113, times the square root of 9. Okay, so theta is equal to cosine inverse of that. And that is 41.2 degrees to 1 decimal place. And that's all for this question.